How we doing? So you must have completed chapter 5 if you're looking at this video, and again, as with the chapter 4, my goal is to help you debrief the chapter, and particularly the chapter questions. I want to start with the following thought. The United States is in a very unique location on the planet. North of the United States is the polar regions, south of it is the tropics, and in between is a big flat landmass, with the exception of the Rockies. And the Rockies are the only major north-south mountain range, or we have a north-south mountain range, in contrast to Europe and Asia, which have an east-west mountain range. Now, what does that mean? It means that here in the United States, you have continental, polar, and Arctic air that can work their way down into the country. You have maritime tropical air that will work its way up into the country, and occasionally continental tropical air that will advect its way eastward. However, when continental tropical air works its way eastward, fairly quickly it will modify and become maritime because it'll pick up Gulf moisture. Bottom line is this area here that I'm outlining is the battleground. This is the battleground. This is where cold meets warm and you see wide swings, and of course it's April in New Jersey and you see you're in the middle of that. So let's take a look at those chapter 5 questions. Number 9 on page 138. How does radiation fog normally form? Very simple. Fog, as you learned, is a form of condensed water vapor, and it'll form when the atmosphere saturates. If you have a clear, calm night and the temperature can fall very quickly to near the dew point, or even very slowly to near the dew point, what you'll see is the formation of fog, ground fog. Radiation fog and ground fog are basically the same thing. We call it radiation fog because it occurs as a result of radiational cooling. That is, the energy the Earth has absorbed during the day is radiated back into space, and in the absence of clouds, the absence of wind, and the absence of a lot of humidity, that can happen fairly quickly. That's why some days, especially in spring, may warm up to 80 or 85 degrees, and then very quickly, by 7, 8, 9 o'clock at night, you know it's not summer. So the temperature has fallen very significantly. All right. Why are high clouds normally thin, and why are they composed almost entirely of ice crystals? Well, the higher you go in the atmosphere, the colder it is. So in the very high atmosphere where it's very cold, you're not going to find a lot of moisture to work with. So as a result, high clouds are thin. In number 16, lightning, continuous rain or snow, hailstones, and an anvil top. All right. What we really need to do is consider what are the weather systems that really result in producing this. And I'm going to bring up something called cyclones here, which is going to help you visualize what it is we're looking at. So here we go. That's moving things around the way I want. Here's the center of a low pressure system, a storm system, if you will. A mid-latitude storm system as compared to a tropical system. Now, a mid-latitude system has fronts attached to it. Basically, these fronts represent the boundary between much warmer air to the south and much colder air to the north. So if I move this barb over here, I'll notice it's 30 degrees on this side of the front, 50 degrees on this side of the front, and if I move this back here, a similar contrast, 18 to 50, 50 degrees in the warm air, 51 if I moved a little further south, 52. So these are idealized conditions, and this is obviously winter, what we're looking at. Now, what I want you to understand is clouds occur as a result of fronts, and we'll talk more about fronts when we get a little further into this, but you need to understand there are 3 types of clouds: high, medium, and low. Now, the higher clouds would be further from the front. These are cirrus clouds. You can see a little symbol there, CI, and I'll just bring up the key for this, move that up kind of off to the corner. So you've got cirrus clouds followed by lower clouds, stratus, followed by lower clouds, nimbostratus. Your nimbostratus ahead of a warm front are where you get your continuous rain and snowfall. Light rain, light snow, moderate snow. It's the cold front where life gets interesting. See that little CB there? CB represents cumulonimbus. And for the cumulonimbus cloud, right there, that's your thunderhead. When you see towering clouds in the atmosphere, when you see the big puffy billowy clouds, Well, if they're not too puffy or too billowy, they're cumulus clouds. But if they get really puffy and billowy, they're cumulonimbus clouds. Cumulonimbus clouds, just know this, associate them with thunderstorms. And what do we associate with thunderstorms? Well, we should associate with thunderstorms lightning, thunder, hail, severe weather of other types like tornadoes, high winds, straight line winds. Fortunately, straight line winds and tornadoes are rather rare in New Jersey, but the others are not. Hail is known to occur, and certainly plenty of thunder and lightning. All right, so that might give you some sense of the answers to 16. And because the cumulonimbus cloud gets so high in the atmosphere, when it reaches the tropopause, the top of the troposphere, it's forced to spread out since it does not usually cross into the stratosphere, and therefore you get that anvil top. So again, you've got your answers to number 16. Skipping ahead. Geostationary satellites from polar orbiting. Well, geostationary satellites, and I'll bring up a web page on this, some great background information on geostationary satellites right here on weather.unisys.com. So if you just went to this, weather.unisys.com, and then clicked on satellite images, and I clicked on visible, you can look at all kinds of current images, and you also have a more information page. The more information page will supplement what you already have in your book, and I encourage you, take a look at this. I think there's some great information in here, and read through at least enhanced infrared satellite images. Now, so here's what I want you to understand. Here's what we need to know. A geostationary satellite is a satellite that is orbiting the Earth, but it's geostationary. That is, as Earth rotates on its axis, all right, the satellite is moving along with the sphere. So by placing the satellite 22,400 miles in space above the surface of the planet, which by the way is about 10% of the way to the moon, a couple of things are accomplished. First of all, we get a real widescreen photo. Not real high resolution, but real widescreen. So that one satellite image, if I go back, for example, to the visible satellite, if I click here, this is actually two satellites. One is covering the eastern half of the U.S. and the center of out into the Atlantic, and the other one is the western half of the U.S. and out into the Pacific. The eastern one is called goes east, and the western one is called goes west. But because they're so high, they get a pretty global, pardon the pun, photo. Polar orbiters are generally not used for weather. Polar orbiters are more for military purposes and such, because they're only orbiting at about 300 miles above our surface. So at 300 miles, they can't get a real wide swath of the Earth, but they get a real detailed look because they're very close to us. All right. So, enhancing infrared images. Well, if we go to a water vapor, an infrared image. Here's an infrared image, the latest infrared image. You can see I'm recording this on the 17th of April 2010. And you've got, at this point, a major front stretched through the mid-Atlantic out into Oklahoma. And actually, the head of the low is back here, and I know there's snow occurring up in northern New Hampshire and Maine as we speak. Now, this is somewhat revealing, but if I go to an enhanced infrared, it's more revealing. It'll show me where the coldest cloud tops are. Now, why do I care about that? Because those are your highest cloud tops. That's where the thunderstorms are most likely. So if I'm looking out here in central Oklahoma, in parts of Texas, and off the Florida coast, these are areas that I would think are areas of interest where we might want to take a look and see if there's any indication of thunderstorms occurring in that area. And of course, radar might be a more valuable tool for our purposes to look at that. All right, skipping up to the questions for thought. Looking at those, explain the reasoning behind the wintertime expression, clear moon, frost soon. Go back to my early comments. That's why. Clear night, great radiational cooling, lose the heat from the surface, don't have a lot of moisture in the atmosphere, and you're going to have your temperatures plummet. You're going to want to re-listen to that. Okay, so clear nights are frosty nights, especially in autumn and getting into winter. October, November, perfect time of year, occasionally late September. Icebergs surrounded by fog. Simple. For number 2, think about it. An iceberg is made of ice. It's cold. It's probably colder than the air. If it's colder than the air and it's cooling the air down to its saturation level, remember, cool the air and it can't hold as much water vapor. That reminds me, I have a link here. Take a look at this, howstuffworks.com/question651.htm. Just grab this website address and you can see a bit more about relative humidity and how it affects how we feel. Anyway, so icebergs cool the air, saturate the air just by cooling it down, and that creates the fog around it. The same answer might apply to number 8 with Arkansas. When Arkansas has snow on the ground, if moisture starts coming up out of the Gulf, or air comes out of the Gulf, it's going to bring with it moisture, and when that moisture gets dragged up into Arkansas, what you're going to see, if there's snow on the ground, is a lot of fog, because the snow is cooling that surface air, which probably contains a lot of Gulf water vapor. When I say moisture, I mean water vapor. It's one in the same. And of course, when it condenses, it's condensed water vapor, otherwise known as condensation, most commonly called fog or clouds. All right. New Orleans example, same idea. Number 3, you got cold glasses. Your glasses are going to cool the air surrounding them, and that's going to force condensation to occur. No different than the example I gave you in Chapter 4 about the soda bottle out of the refrigerator. Skipping number 13. Number 13 is along the same lines. You breathe out, you exhale very moist air. If you're putting a lot of moisture into cold air, the cold air cannot, quote-unquote, hold the water vapor. Therefore, the water vapor is forced to condense. Hence, you see your breath. And 15, how do you tell if it's Nimbostratus or Cumulonimbus? Remember what I said before. If we are looking at a cyclone, the Nimbostratus are going to be ahead of the warm front, and for reasons because of the way warm fronts are structured, they produce prolonged periods of light to moderate precipitation, rain, snow, sleet. On the other hand, this front will produce towering clouds, hence you're going to get cumulonimbus, and hence you're going to have very short, potent rainfall. Cumulonimbus clouds are most noted for brief outbursts of extremely heavy rain. All right, with that, continue your work, and your next chapter will be 6.